So first of all, please let's take a picture from here, because all the day we have the other perspective. So think about not having system D. So I don't care, but I want the picture. So, okay. So let's take the next 20 minutes talking about Icinga. So my name is Bernd Erk. It's hard to say it not in German. It's even hard to say it in German, but anyway. I'm working at NetWays. I'm one of the co-founders of the Icinga project. And I'm still in the project organizing stuff and taking care of the community. So a quick poll. Who of you knows what Icinga is? Who uses Icinga for monitoring? Okay. Who has no idea what Icinga is? Okay, that's fair enough. So Icinga is an open source monitoring tool. So what we do in general is we monitor stuff, we monitor availability, we notify users, we are able to start event handlers and try to fix it. We create data for business intelligence, for reporting later on. So our history is in Nagios. So we are a Nagios fork. We started forking Nagios in 2009, I think in April. It was around Easter. And since about June 2014, we have our own independent core, which is Icinga 2. We redeveloped it from scratch, so there's no single line of code from the old Nagios in Icinga 2. And we are working heavily on that, and this is, so Icinga 1 is still under maintenance, but all the new features, everything we do, all our efforts now going in Icinga 2 and also in Icinga Web 2, the new interface. So what Icinga does, it monitors everything, and we are using the power which Nagios has with millions of plugins out there, so good and bad plugins, but a lot of plugins. So we can really monitor everything. We gather the status, which is pretty simple, like signal, green, it's okay, yellow, it's so-so, and red, it's not okay. And we also collect the performance data. So every round trip we do, checking a service or a host, we try to figure out is the performance going well. So response time of a web server, for example. What we do is with that information, we can notify a user on probably any channel. So we can send them an email, which is the default, but we can send them a text, or we can probably make a phone call, which is the best notification, having a phone call to force your user. Let's press 1 if you acknowledge the thing. It's the most complicated thing to set up, but it's probably the best. We can consider dependencies like network relations, network zones, where we rely on a specific router to access a specific area of your network and handle that. And we also can handle events, for example, restarting a service or work on that. Reproduce a lot of data means we can easily forward data to other tools using Graylog or using Logstash, using the GAL format. We deal with the performance data itself that we don't have a graphing add-on, but we can work with various of them. We can see that later. And we provide SLA data in the database. So we support MySQL and Postgres, where we write all our data in, and you can use it for reporting later on, which you can probably send out to a user every week and report the availability of a specific host group. So just a little bit about the architecture, and then we come to the part which is probably more interesting, which is important. So if you know Nagios, and if you know also the old Icinga, you know that we have a problem using more than one single CPU because it's a single-threaded loop. Icinga 2 is multi-threaded, so we redeveloped it in using C++. It really scales very well. Load is distributed, so if we use multiple monitoring nodes, we distribute our checks and distribute the load on all the nodes. And we can monitor in a second interval. If you execute a 100 megabyte Perl plugin every second, 200,000 times on one server, you can have a problem. If you do that with a very nice small C plugin, you can really do so and monitor a switch or whatever high important component of your environment in a second interval, so you can do so. Just to give you an idea, the Icinga core itself provides a couple of features. You can enable or disable them, so it means the heart of the monitoring is that we parse the configuration, take care of the logging, but everything else, like writing perf data, writing data to Graphite, or writing data to GALF, or writing data to the database, could be enabled or disabled on your wish. So You can have multiple nodes in a mashup cluster using SSL communication, and you can decide which feature you want to. For imagine you have a 2-node cluster. You say, I only write graphite in one data center, and then you can disable the feature on the other thing, which is probably important to understand what our vision is. We don't want to reinvent all the things out there. They do great jobs in graphing and logging and all these different disciplines in systems management. So our focus is that we are the best in monitoring. So we are the best in taking care of that thing, configure things, take care of things. But we don't want to take care of create the graphs. We want to provide the data. We want to provide the data for BI, for logging, for whatever tool, and also want to make it easy for others to integrate with us, like Chef and Ansible or whatever out there. But we don't want to do it on our own. So monitoring OpenNebula, I just split it up in kind of 3 perspectives, what we want to do. So I don't know what you want to do, but it's just my imagination. Perhaps you want to do so. One thing is availability. So the basic thing in monitoring is still, are you alive? That's the minimum you want to know is, are you still living? If you perhaps want to go to the next level, talking about capacity, do I have enough space? Do I have enough resources to add additional virtual machines, for example? And also, you want perhaps a view which has nothing to do with a specific disk or a controller or a network or a specific facility in your environment. We just want to create something like a business or a customer view, which gives you, at the end, if you have 1,000 nodes, give you a big OK. System is up and running. And you don't care about all the details underneath. So talking about the availability, for me, it's just a couple of things. One thing is the physical infrastructure. So perhaps you are interested if a node is on fire. You should definitely monitor your hardware. You can use this with a couple of plugins, and there's not enough time to explain you about the 1,000 plugins available out there. If you want to monitor hardware, IPMI is a good idea, and there are a couple of good plugins for monitoring IPMI devices. All the OpenNebula services, probably you know them better than me, but monitoring services is pretty easy in there as well. There are a couple of standard plugins coming with the monitoring plugins project, but there are also a couple of definitions also makes it very easy. And the other thing is, are there specific interfaces or APIs available? I just took that picture to perhaps make it a little bit more clear what I mean with that. Having the physical infrastructure at the bottom of your cloud, having all the services you want to monitor, perhaps specific APIs, see if the one daemon is up, and especially also getting an end user perspective, setting up a REST call to a specific API. This is what you can do every 5 minutes, every minute, in whatever interval to get a feeling, is your cloud responsible? You can do that with standard checks. So I would say every component OpenNebula has, and it's freaking easy compared to others. It's very easy to monitor them. So just use the standard checks. Try to get everything you can monitor. Try to collect everything. So do a little bit like the NSA big data approach. Get everything. Take care of the metrics. So try to use plugins which are able to generate performance information, and not only the simple available information. And use a scalable configuration. Means if you have a cloud framework, it could happen, hopefully, that you add hosts and not delete them. So you add hosts and hosts and hosts. And if you do that in some monitoring tools, this could be really tricky. And just to give you a tech example how that could look like, this is probably a typical Nagios, the old Icinga configuration, which you had every service or host you had to add manually again and again and again. And it's really just a simple example. But to give you an idea what you can do with Icinga 2, you can work with something like these supply rules. So you can define specific templates, and then you can add some tags to hosts, which is something like if you're working with Puppet, like effect. And you can say a specific host is a variable, and you can use it using this template language. So we focused very much in Icinga 2, working more on a rule-based approach and not having 3,000 lines with every server again and again. So we just add a server, add a couple of attributes which are important for us, and then work on this rule-based approach. With the new version of Icinga 2.4. It's coming up in November. We have a full REST API, so you can add hosts, delete them, modify them, everything you want to do them without restarting the core, just on the fly using a REST API. But this is not ready. But the Git master is working. So if you have the time, want to play with a Git, it's open source. You can do so. Coming to capacity, there I think are two types. One thing is the physical capacity. So do I have enough resources in my system? The simplest thing is perhaps do I have enough disk space on my Ceph or my NetApp or whatever storage component? And also is my service performance good enough? And doing so with Icinga, there are a couple of ways. A very simple thing is like using RRD-based graphs with add-ons. This is a screen taken from P&P for Nagios, which is a simple RRD-based add-on. We just take the performance data out and put them in. It's very easy. The problem with this is that it's hard to combine information from a couple of hosts and services together in a single view. So you can do so in RRD. So if you're really familiar how RRD works, you can do that by hand. But typically, you have an RRD for every service on every host, and this is really hard to create some kind of overview what's really going on. What's really popular right now is something like Graphite. So how many of you are using Graphite or InfluxDB, which is not the same, so equal? Somebody don't know it, what it is?
Very flexible display thing that can Graphite, very flexible display thing, right?
Right.
They can take any metric, give it a name, and give it a metric, and it puts it up.
Yes, indeed. So Graphite is getting more and more popular. InfluxDB is something which provides the same API. They try to fix some yeah, I don't know. The installation of Graphite could be tricky, but Graphite is very popular because you can just put every metric into it. At some point, perhaps you should add another server if you put more and more into it. It has the same principle, but it's more flexible, like adding also old data to these WhisperDB files, underlaying the Graphite. So it's very easy to interact with it. And for example, if you want to put data into Graphite from Icinga, it's just like a single CLI command. It's just say Icinga feature enable Graphite, and that's it. And then you have a config file where you can say, here's my Graphite server, which an IP address and a port. And then all the performance data you gather in your Icinga environment, monitoring your APIs, your storage, whatever, automatically went to Graphite. And then there are a couple of web interfaces. So there's a Graphite web who's, I don't want to say it's super ugly, but it's not super hot. So you can see something. Which is much, much better is something like Grafana, which is it's a front end for Graphite. And for example, here you can see network usage. Perhaps the dark screenshot was not the best idea, but hopefully you can see that. Here's a network load you can see. Or for example, in the next graph, you can see all the Ceph exporters we're using. So every line here is a Ceph node. And then you can combine all the data of a couple of hosts and services in a single view. So this gives you the chance to really create specific dashboards on data not bound to a single server, so you can monitor your whole environment, all your storage nodes, all your compute nodes. It's just two examples. I have a couple of screenshots, or you can also see it live if you want to. It's pretty cool to get an overview and see more than a single host, so see your application. And so coming from availability to capacity, one other thing is the business view. Means perhaps to another audience you want to hide if you really have a RAID controller problem or a single disk fails, or perhaps one of your storage nodes or Ceph nodes has a problem. You just want to create something like a big picture. Therefore, it's necessary to hide the technical details because you don't want them to see. And also differentiate different outage types. So for example, if you have multiple zones and it's only important for you that one is up and running, you perhaps want to hide it. And also want to see if the service in general is not okay, have something like a top-down view. And what you can do is, I don't have a live demo because I think there's just not enough time. We have something in Icinga Web which is the business process view. What you can do with this business process, then you can see here that I have an OpenNebula process, which is probably the big picture, is OpenNebula okay? And then you can combine different services like an API or storage and can say something has to be available. It's like these hopefully you can see it. It's like and or. Means a couple of services has to be available to have the complete system in order. But there could be others, like I have 2 API servers, for example. It's enough if only one of them is okay. So having like an and or rule set that can be nested on whatever level dev you need. But this is very flexible because on the biggest things, so on the top level, you can just put a business process check on the top level and just alert on that. So you can just see if my whole process, if my whole service is a problem, then I want to get alert or want send an email or a text message to the manager. But if something is red down there, then I don't care. So manager doesn't care, so you have a big green until all your components fell out. So you can play around with that. You can download the background boxes, say background up, and then you have a fully working example if you want to play with it on icinga.org/download. And then to be in time. A conclusion. Definitely, if you're talking about monitoring, and this probably fits to OpenNebula as well to all the others, think about different perspectives you have. So monitoring is not like, I want to monitor everything, let's auto-discover my whole network, and then I have 300 machines, and then I have big, green, yellow, red, whatever. So really think about for what kind of audience you create monitoring. So for the guy in the data center who is responsible of the physical hardware, and IPMI monitoring could be interesting. But for somebody who sells your service to another customer or to your company, they don't care. Try to monitor everything and deal with it later. So probably don't notify on everything, because this leads to a whatever mail client rule to move it to the trash. Check the service availability, and definitely work with these business processes, because they are very easy to get an overview on an eagle eye approach, and it makes it easier to find out what's going to happen. And of course, use Icinga too. I'm absolutely in time, 20 minutes. Thank you very much so far. Are there questions?
Any questions? Okay, yes.
Hi, I'm Arie Bikker from Amsterdam. Does your software cover the dynamics of a virtual environment? For instance, would it be possible to assign a parameter to a template of, say, a worker node, which on instantiation would then be put into the list of things to monitor?
Yeah, that would be possible. For example, if you defined a template for, let's say, just for example, compute node, and say my compute node needs about these 20 checks because they are important for my compute node. And then you add a new node with the API later on, and then you say add one node with the specific text. Then automatically at the point of your command execution, the templates are evaluated again, and all the service checks defined on the template are attached to that host without needs to be restarted, the Icinga core. You can just add a host. We had an example with also a couple of cloud interfaces. We just can query how many hosts are there, and if you detect a new one, we just add the host, apply the templates, and then you have the service checks.
Yeah, and that's on the top side, the individual VMs. I would also be interested in a VM, an OpenNebula setup where during certain times you would turn off certain VM hosts, and that they would automatically not generate any notifications of being down anymore because they were brought down on purpose.
You mean if you delete an OpenNebula host and then want to kill it in the monitoring system?
At 6 o'clock in the night we're going home, so we put that one off.
So one thing is you can do, but perhaps you know better with the OpenNebula, you can have something like a hook in OpenNebula. So if the machine goes down, and then you can just execute an Icinga to rest command, and then delete the host. So we can also set a downtime, which could be flexible, means I say a downtime happens sometimes, and if it starts, the server goes down the first time, then it lasts for an hour. Or you can do a fixed downtime from 2 to 4, or you can just use a hook and say, if I kill the machine in OpenNebula, then I want to delete it from the monitoring system. I would do so.
Thank you.
You're welcome.
One more question over there.
Yeah, I have a question about the business process function. Do you need to install extra software, like extra MySQL servers to store the data, or run a Tomcat application server to run this specific business intelligence part, or is it just part of core Icinga?
It's part of the core Icinga. Right now is the case that Icinga, especially Icinga doesn't need the database, but the web interface needs the database. So Icinga writes all the data into the database, and the web interface works on top of that. We have plans for the future. Now we have an own API working with that, but right now you need Postgres or MySQL, write the data in. But the business process add-on just work with classical check results, and the rule set is just in a text file. So these rules set how a business process should look like, these and/or combinations, you can generate them pretty easy. It's just a text file, and every time you probably do a refresh on that, it just checks the current states out of the database if they're up or not, and then generates the whole result. So you don't need anything extra, just the typical standard Icinga 2, Icinga Web 2 installation, and then the business process module is just a module. It comes into the web folder like a WordPress plugin, let's say, and then you just activate it, and then it's here.
Okay, thanks.
You're welcome. You got a question?
Is Icinga compatible with things like CheckMK or the OMD distribution, the talk to Nagios?
Okay.
Compatible with CheckMK or OMD distribution?
There are two things. So OMD distribution is something where a couple of components are bundled. So they have CheckMK, they have Nagios, they also have Icinga 1, and now the newest version have Icinga 2 as well, which makes it's another approach, making it a little bit easier for the user to just install it. CheckMK, which is also an add-on, and they have their own interface. It's another product, so it's not compatible. Also CheckMK, the agent approach, right now it works with Icinga 1, but because in Icinga 2 we have a different configuration language, it does not work to auto-discover the host in there. Our approach is because it was very popular using old Nagios doing, I don't know, get the source, configure, make install. You want to provide the packages, make it easy using CLI commands, enhance specific features like IDO. It was a mess working with NDO utils in the past because you had to compile it and all the things. Everything is included, just use the package, enable the feature, and that's it. Okay?
Okay, thank you. Thank you,
There's
Bernd.
another
No, I think we should.
I think we're running late, right?
Yeah, we're quite behind the schedule, so we'll leave that later for the open discussion and during the dinner, if you don't mind. Sorry about that. So let's do a quick break for coffee. Let's say we come back at 4:10, okay? So thank you.